In this video, I'm going to describe the literate practice of taking an inequality in symbolic language and turning it into a line on a number line that represents all the solutions or values for x that would satisfy that inequality. So the first thing we need to do is look at what inequality symbol we have. In this case, we have x is greater than 3. So this means that x equals 3 is not a solution. So we're going to look at our number line, and the point on the number line, +3, we're going to draw an open circle to represent that if x equals 3, it does not satisfy the inequality. Now, our inequality tells us that our solutions are going to be values of x that are greater than 3. And on the number line, we see that the values greater than 3 are to the right on our number line. So we can draw our arrow heading off to the right. A convenient tip is that if you have your inequality written with your variable on the left, your arrow will point the same direction as the inequality symbol. You just need to make sure that the variable is on the left. Otherwise, that rule does not apply. Let's look at another example. So, this inequality is telling us that x is less than or equal to 5. So, first we're going to look at our number line. We're going to see the number 5. And because our symbol says x is less than or equal to 5, we know that 5 is a solution and therefore should be a part of our line. So this time we're going to draw a solid dot above the 5. Now, using our tip that I mentioned on our last example, we see that the variable is on the left, and we see that the inequality symbol is pointing to the left. And so we're going to be drawing our line over to the left. To make sure that our rule is working the way we think it should, let's try a test point. So if we were to say x equals 0, is 0 less than or equal to 5? It is. And so that means that we can confirm that we can draw the arrow in that direction. Oops. And that arrow will keep going on to infinity. So these are two examples for drawing an inequality equation as a picture or as a line on a number line. So it gives you a visual representation for the equation or the inequality. Now, the last example I'm going to show you guys is a compound inequality, where we have our variable being defined by two different inequalities, in this case written all together. So we have 1 is less than or equal to x is less than or equal to 3. The best way to go about translating the equation into a picture is to look at each piece individually. So first, we're going to look at what the line would be if we just had x being greater than or equal to 1. Then we're going to look at and draw a picture for x being less than or equal to 3. And then finally, we're going to draw our third picture, which will combine the information that we see from the first two lines. So let's start with looking at our red. So we look at x is greater than or equal to 1. I'm saying it backwards. 1 is less than or equal to x. So since the symbol is less than or equal to, we're going to draw a solid dot at 1. And this is a case where that rule, because the variable is on the right, the trick won't work right away. So we're going to have to plug in a point and test this. So if we had x equals 2, 1 is less than or equal to 2. So we see that this arrow will be going off to the right. Now let's graph x less than or equal to 3. So, similar as before, we're going to have a solid dot at 3. And we can use the tip this time because x is on the left of this inequality. So we see that this line will be drawn to the left. So now we see how each half of this compound inequality works on its own. So now our final answer is going to be all the solutions that are a part of both of these pictures. So you can see how 1, if x equals 1, it's a part of the red line and it's a part of the blue line. If x equals 3, it's a part of the blue line and it's also part of a red line. And if it's anywhere in between there, if x equals 2, say, it's also a part of both lines. But if x equals 4, it's a part of the red line, but not a part of the blue line. So our final solution is going to be a line segment from 1 to 3. That'll include all the points that are a part of both halves of this compound inequality. So our final picture for this question, where we wanted to take this compound inequality and represent it as a line segment or as a line on a number line, is going to be this line segment from 1 to 3. So I hope that this helps you understand how you can represent an inequality as a picture.